Welcome back, guys. This is going to be the second part of our video tutorial series on Visual Studio unit testing. So if you have been following from the first one, so basically we have this little unit test here. So we have this assertion on line number 43 that basically saying the very first record that is sorted from the file would be valued 48 AAA. But let's go ahead and run this test here. And let's see the result of it. It is basically saying, hey, you are expecting value this, however, the first value that we found is Aaron. So let's see, which kind of makes sense. And let's do a couple of more unit tests here. Let's see the second and third values also. And let's say the second name would all be okay, we don't know what the second value would be. Let's go ahead and run this unit test, but one of them going to fail. I'm saying all three are Aaron, which might not be the case because those names are unique, I assume. Okay, we have a failure again. So, but it is telling us, hey, that it is failing because the value in the second one is AB, it's not Aaron. So ABBEY. Let's go ahead and run again. Let's see what the third name is. Okay, third is the one with the AB. ABBIE. Okay. At this point, it should be green because based on our logic, it is saying, alright, it passed. Our unit test, all the three unit tests, all it is saying basically, hey, this is the first name. And just by looking at the alphabetical order they are coming in, they could be sorted alphabetically. Okay, that sorting logic is now complete. Let's go back into what they want us to do next. All right. Then working out alphabetical value for each name. Okay, let's implement that logic. So basically, we need to have alphabetical name for example. Okay, for A, we're going to assign value. So to do that, let's go ahead and write some unit test here. Assign alphabetical, assign numeric value to alphabet. Just make it up, okay? So let's write some, and we don't need this unit test here. So the idea, we need to write some logic here. So what the logic gonna say, if let's say my expected value would be 1, and if I pass method, let's see, this method doesn't even exist yet. So I'm going to say get value, get the numeric value from alphabet, numeric value for alphabet. And let's say I'm going to pass string A. So basically, I'm asking, hey, if I pass you A, you have to give me result 1. If I pass B, you have to give me, let's write a couple of unit tests here. And the same way, if I pass the letter G, I expect to get value 26. Something like that. And of course, this method right here doesn't exist in our in our class. So we can ask Visual Studio, hey, go ahead and create that method for us, generate that method. Okay, that method created, and if I run this method, this unit test method now, it is still going to fail because it is not implemented exception, which makes sense, right? If we go in here, it says, hey, that method hasn't been implemented, which is good. That's what we want to see. And when you go ahead into our class, and we're going to implement that method. Okay, that's good. This should be pretty easy. I'm going to say alphabet, meaningful name. So how do we, I don't know, so there's several ways we can do it. We can create a dictionary and store all those names in there. So let's do something like this. You see alphabet. Very first thing I'm going to do, I'm going to make sure it's doing to lowercase here, so that it would, doesn't matter whether uppercase or lowercase, it would work. We always work in lowercase here. And let's all alphabets. So basically alright, this is our alphabet here. Okay, once those alphabet is defined, we basically, let's simply create a dictionary with a key as a passed in alphabet and corresponding value integer. I'm going to say alphdix. Just for now, we will give a nice variable just to make it work right now. Just okay. So these are pretty simple implementation, so you don't really have to, you can implement whichever way you want. All we're trying to do is trying to get a numeric value given the string representation of the alphabet. So I'm going to say write some loop here, and I'm going to go through all the alphabet, grab it. Of course, this could be written by using lambda too, but I'm just writing very simple implementation. And then we have dictionary here. For the given index of that dictionary, we basically gonna give some value. Let's define a little variable. Let's say I'm gonna say that's counter and set it to 1. Index, and here is give a counter value. And of course, on each iteration of the loop, I will have to I mean to do something like this. Here's my alphabet. I'm going to add. Here's my dictionary. Into the dictionary, I'm going to add a key value here. Key would be whatever the key. Key would be basically our alphabet, all alphabet character here, whatever value is in the index, and then let's say the corresponding value of that one would be counter. Okay, of course it is we have to make sure, because it is a character, but we have to convert that into a string. Right now, of course, if I just do this one, we will have all of them would have the same value, but that's not what we want. So we have to make sure we increment our counter. Oops. So on each iteration, and then of course we have to return the corresponding number, and this is our alphabet here. And so basically we're going to say go ahead and return our dictionary now contains our fully saturated dictionary contains that value, and overall I'm going to say alphabet here. This implementation is a very fast implementation. Of course, we definitely make it better. So I'm going to go ahead and save, and assuming everything is okay, there is no duplicate value here, our unit test should pass. Let's give it a try. Okay, so it's definitely didn't pass. What is the error? Okay, an item with the same key has already been added. That means, I definitely have, typo in my when I wrote those whole alphabets. Let's see what is the problem here. I need to. Oh. Okay, let's give it a try. For some reason, it found there was a duplicate. If I go into the unit, if I run the unit test again, still failing. But why is... Okay, the given key was not present in the dictionary. Okay, that means our implementation is not working correctly. Alright, so I make sure this is lowercase here, and then I go through index 0. Since I'm starting from 0, I have to go all the way. I have -1. See, this is a classical developer mistake, I think. So that's why they couldn't find, maybe. The given key was not present in the dictionary. Still, it doesn't like it. So starting from 0, going less than or equals to. What is the problem? Oh, there's a duplicate test here. I'm gonna do one at a time here, okay? Let's see if this is working. Given key was not present in the dictionary. Why is that? Here is alphabet. Make it the lowercase. And here's my dictionary. Oh my goodness, here is a typo. I mean to say, I give a key as the whole alphabet. This is what I mean to do. See? That was... Yay, at least the first one passed. Let's make sure the second one, when I pass B. Run again. Okay, let's do some boundary condition test here. If I pass letter G, what happens? Run it again. Okay, at least that method is good now. Okay. So let's what we started with. Now we have a sorted record, and now we have a private little method that can give us, given the string, it can give us this corresponding value. Multiply this value by alphabetical position in the list to obtain a name score. So at this point, we are in, basically we should be able to calculate something like this. And then let's write a method that, given the name as a colon, it should be able to give us this little string. Okay, that would Of course, we're not done yet, but that would give us some idea that we are in the right track. So write little unit tests again. Of course, our implementation, this example was pretty simple one. Of course, you don't have to go through all this detail, but in real life, when you're writing software, your logic might be much really complicated. So you want to make sure everything is covered, all the boundary condition is covered by your unit test. Let's copy this whole thing. Okay, that is done. Now, given the name, our methods should be able to give us the string containing the digit. So let's say I'm going to say assign numeric value to name, something like this. And in here, I'm going to say the numeric value for this guy, which is colon, is 53. Okay, let's go ahead and do that test here. So I'm going to say I will be getting value 53 if I pass this string colon here. Oops. This name colon. And get rid of these two. And okay. Assign value to name, which doesn't really exist yet. So basically we are now writing a little piece of logic that we need, but even that logic has a unit test. Let's go ahead and create that method into our main class. Alright, and every time you have some code, we can run our unit test, and we're going to see it fail. That's the idea about test-driven development, so it's a failing right now. We go inside the implementation of that method inside our class here. Okay, now where does it create that method? Didn't create. I thought Visual Studio. Huh? You just rename the other method? That's not what I wanted to do. Why did he do that? Oh, I generate the method, I use something else. I renamed my previous method because the name kind of seemed, that's not what I made a mistake. Sorry for that, guys. I mean to create a little method here. Okay, now we have that method. Okay, just say this is the name. So once we have that method, what we can do, we basically iterate through all the name, just little, we need a little loop here. Starting from 0 index, so alright. So on each iteration, we're going to pass that one character at a time, right? So the idea is we're trying to find the sum. Let's say let's define sum as a long data type and set it to 0. On each iteration, we're going to say sum equals to sum plus get. We have this method previously tested and working, and we're gonna pass it. Expect to pass alphabet, so we can say name, and we can pass the given index here and to string. Otherwise, that will be a character. And we have a typo here. So return the sum, right? That's what we. Okay, it's. I want to say it's going to return long data type, not integer. Okay, there is one reference in our unit test. So basically, we have a name. We basically processing the name one character at a time and getting the corresponding value to it. Okay, that is the purpose of this method. Let's go ahead and run this unit test, and if this pass, we are in a good shape. Okay, it failed. It says expected value was 53. Expected value was 53. Actual value was 39. Something is weird in our implementation. We were expecting 53. That's just okay. See, this one is telling that our previous method might not be correct. Or is it? Ah, don't you have to do less than or equals to here to run the unit test again? Yeah, it passed. Okay, that's it. See, like, you know, as a developer, we know we make so many mistakes. That's a little one, trivial one. Sometimes if you don't have a unit test that doesn't catch it, this code might be, you know, might creep into a QA environment, or eventually sometimes even might go into production environment. The idea is to emphasize, hey, having unit tests in your project is very, very important. Okay, so this thing is passing too. Now we are getting closer. What is the next thing we have to do? So the idea is we need to, we have calculated this one. Now next thing we have to do, we need to find the, for example, this guy named Colin. Once we sort our record, he belongs in this 930th position. We need to find that position here. So so how do we do that? We need to find the index number. So to accomplish that, I want to get like encouraged. It would be a good idea to have a name of the person, the calculated name of the text, like Collins, like 53, and his rank. Let's say to accomplish that, we can do. I'm thinking. Of course, you can accomplish this using so many things. Perhaps you can declare as a tuple because we want to get 3 pieces of data. Or you can give your own custom class. So whichever way you like. I'm gonna, so what I'm thinking, I'm gonna add a little class here. And I'm gonna name it as a score item, a class. This score item will have 3 basic properties here. The first one going to be a string, and I'm going to call it name. That's the name of the person here. Let's copy and paste these guys here. Okay. The second property is going to be the score. I'm going to call it data type. I'm going to name it as a long, this score. And the third one is actually corresponding index. And the index also can be long. Okay. All right, we have this very simple class. So basically, once we have this class defined, now what I can do, I'm gonna come in. We can write some unit tests again. Let's see. I'm gonna write unit test. And this is going to return a score item, and we'll say get all score items. And of course that this is a test method. So now we can write our cross assertion here. Oh, I'm going to say unit method always the void method. Okay, so it's not going to return anything. So I'm going to say 644, just some random number, and I'm going to say to this class that I'm going to give the same name as the unit test name. But these are like, there is some convention you want to follow, but it's totally up to you how you're going to name this method. I have seen some people name it as a test method, but they're already inside the test class, so which is redundant. But some people write as a gate and underscore. Like the intention is very clear. Like it's something called behavior-driven development or something. But in the beginning, you don't have to go into that detail. Since this method doesn't exist, we can go ahead and create one. This guy is already providing us hint. Hey, you want to create a stub? Okay. As we did before, of course, it's going to fail because we don't have any implementation done. And go back here. Oops, not there. In our main class and write some implementation. It's not going to return the. We're going to return score item. This is what this method going to return. We little bit of code, and we come here into our test, and we're gonna say the length or the count. We expect to have that many count here. Okay. Of course, it's gonna fail as you guess, and we're gonna go ahead and put more logic into our code. All right. So this is what we have to do here. We have all our data sorted, and I'm going to create we have this method, get all sorted records. We can ask that guy to give our record to us. So my sorted records, get okay, we have a sorted records list of sorted records here. Then we basically we can write some for each, or we could have use some sort of projection also. So I cannot record in sorted record, go through all the sorted records, and on each iteration, so what we have to return is this guy here. Let's create an instance of that guy. Okay, once that is defined on each iteration, we have sorted records. I'm gonna add new score item. Not Oh, I named the same two variables. Oh, I'm just going to say record for this one, okay? Okay. And this guy can be sorted records. Okay. In here, we're just going to set this property. The name is pretty easy. It's going to come from the record. Hey, what is... Oh. Sorted item. The name would be just the record. Because that's a string of data. And how do we obtain our score? We basically get alphabetical value for get all score item. We have some method here. We implemented that some method. Yeah. This unit tested method we should be, and we pass this record which to it, and finally we need to find the index. How do we find the index? I'm going to say just for now counter. Of course it doesn't exist. We're going to introduce a variable. This is really a cool feature in Visual Studio. Yeah, generate field or read only property local counter. Okay, I'll just create a local variable. But I don't want this local variable inside the loop, of course. I want to be here, and then on each iteration, of course, I have to increment the counter here. And based on our data, we gonna start with the number 1. Okay. Once that is all done, let's say return the what we're returning is sorted records. Okay. Let's go back into our unit test here. And we want to see how many records it should be. That's our first test. Let's go ahead and run and see the result. Okay, we said, hey, there is a 654, but actually it should be 5,163 unique name in the file. 5163. And if we read into here, his calculated value is 53 and his position is 938. Let's do a unit test of those two. But how do we do unit test of that? Okay. Let's do this. So they are saying you can do 938 position is a column. Is that true or not? Let's see, just to verify our implementation. But it is based on the -1 because start with 0, 938 position, and that name should be column. I don't know. Let's give it a test. Woo, that passed. That is correct. So we can do one more test here. Let's find out his score. Let's find out Colin's score. His score should be 53. So it should be 53. Go ahead and run the test. Okay, pass again. It's a 53. And this is Collins, and then his last thing we want to do, let's find out his rank. Well, this is obvious kind of test because we already know his rank. Okay, things are looking pretty good. Now, the last thing we have to do is, what is the total of all the name score in the files? So that is very simple. Now, we have a bunch of unit tests going on. Everything looks good. So, score calculator. So our original problem, finding the sum of all the score, is pretty easy. So basically, we're gonna get all the score items. Get all the score items, and once you find, you can call the sum method sum in some numeric property, right? So in this case, the score. Okay, that should be it. That should be the total sum. Let's give it a try. That's our original method. Find. Okay, let's give it a try. Let's run this one. Right now I'm asserting it is at 0, so possible it should fail right away. Hey, that is not 0. It is really a large number, 32,045. I don't know how to see the answer, but I'm guessing based on our unit test, it should be 324536. That is the sum of all the score of all those students. Okay, at this point, assume our unit test is good. We're kind of satisfied with the way that things are, because we have not only tested the main logic, all the little pieces that we had to test. We have a unit test for all of them. So at this point, into our API, in this API right here, we have a bunch of public method. Even though they are doing just a little bit of unit testing, we have because we have tested all of them. But eventually, I would. This is the only thing. This is the only API I would really care about. All the other doesn't really add any value to be existing here, because so I would make all of them as a private before I deploy it into production. Okay, so that is all I wanted to share. How to start with the unit testing in Visual Studio and how to take a test-driven approach to it. All right, guys. Thank you so much for watching the videos.